Right. Hi everyone, welcome. I can see a number of people. Welcome, welcome. Please take the poll as you join and also share where you're joining from. Um, Share where you're joining from in the chat. Oh my God. Hi, Alex. Okay, I see Emmanuel from Nigeria. Thank you. Thank you for joining. Um, Hi, Abib. You can either use the Q&A or you use the chat. Hi, Adebayo. Hi, Japhet. See all of you. Welcome. Hi, Alex.
Hi, how are you? Hope you're well.
I am fine. Thank you. Thank you very much. How are you too?
I'm doing very well. I'm doing very well. Yes, I am actually here to just lay the ground and just share some tools and just lay the ground really for the real experts, which are you guys, the tech guys. So from Fumi to Juliana and Bolahon, you'll be the ones answering questions. I will just
Yeah.
set the stage and you will answer all the questions from the
Our,
audience.
our boss is
Oh,
being humble. Our boss is being humble. Okay, it's all right.
yeah, please. Yeah, don't mind him. He's just been humble. Okay.
I'm not joking though. I'm going to talk about some very interesting tools that are above my pay grade, and then the senior people on the call will answer the questions. So please, you people don't drop off.
Oh my God. All right. Welcome, 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 everybody. And so without further ado, we'll start. And the way this webinar is going to go is Alex is our facilitator for today and is going to be walking us through how to deepen your usage of GPUs. Like, what is the extent that you can go with what you're building, especially as regards optimizing AI model on the edge. All right, what's the extent to which you can go with GPUs that are available to you? And so Alex will be expanding based on his experience as a former cloud expert at NVIDIA and also right now as CEO of Udu Technologies, Africa's first decentralized cloud platform. Okay, and also have here with me Julian Duru, who is on the team of the Africa Deep Tech Challenge, and also Bola who's also on the team of the Africa Deep Tech Challenge. And we will be answering questions as regards any of your questions as regards the challenge. So anything GPU, you send it to Alex. Anything Africa Deep Tech challenge, you send it to us. But yeah, without further ado, we'll start out and I'll hand over to Alex. Alex, please, over to you.
Thank you very much. Really appreciate that introduction. And as you said, we'll be talking a bit about the world of GPUs and how that they might be used to speed up your innovation. In the audience, we have many innovators and builders who are working on the Africa Deep Tech Challenge, this specific one looking at low resource computing. How do you build things for a low resource environment? A very clear example, I was speaking with one of such people who's working on this, and they shared how they have all these ideas to work on, but for the most part, they get to use just their laptop. And with their laptop, it can take many hours, more than 5 to 10 hours, trying to test a few things before they now can do the next step. So that just slows down innovation, and that's where GPUs come in. And so with this session, I'll be introducing you to a couple of best practices when you start to use GPUs. But really, the depth of it is your job. Your job is to create models that can run in low resource environments. So I won't be giving expo here on how to do quantization or distillation. That's your own side, but at least showing you the tools that you can use to get there. One of the first things we did, and in fact, let me actually share my full screen. So I'll send a request so I can be able to do that. And then let's see, I believe, okay, cool. Oh, I still cannot share. Let me see. Okay, multiple presenters can share. So in that case, I will just share my full screen since there is quite a bit going on here. All right. So on my screen, you should be seeing a PDF presentation. It says expanding low resource AI innovation using cloud GPUs. As Fumi mentioned before, CEO of Udu Technologies, and this is on the ADTC side. This presentation will probably be like 20, 30 minutes or so that there'll be some time for you to, like I said, ask Fumi and Julian questions. And it can be interactive that way. The first thing we wanted us to do when you came in, I think you saw a poll that asked you, how are you using GPUs today? I saw it, so I'm hoping you saw a poll as well. To confirm, let me see, how do I pull it up? If I click on polls, it shows me the polls, but how do I see the results of the polls?
Okay, we have 38 people who have participated right now. So you should be able to see it as a panelist. Can you confirm?
So when I click on more and polls, I see the poll. I don't see the results. But if you see the results on your side, maybe you might share your screen and show us the results.
Okay, let me see if I can do that. Share. Okay, let's do it this way. Yeah, so can you see my screen?
It's coming up. All right, I can see your screen. So let me lean in.
Okay, so this is what it looks like.
Oh, it's showing a different tab. It's showing your AGH donor
Ah,
dashboard.
okay. So let me take that out then. Stop share. I shared my full screen so that you'd see the poll. It looks like on Zoom you can't share just the poll. So maybe a screenshot is what I'll do.
Interesting.
Yep. So I'll share a screenshot with you just shortly.
Okay, now it
Yep.
works out. And then for participants, I think I see Abib's hand up. We can maybe drop it. The commentary will come later on, just in case.
Okay.
All right. So in terms of screenshots, okay. So I'll bring back my full screen now. I can see this that you sent through WhatsApp. Wonderful. Okay. So 35% are not using GPUs. Google Collab by 35%, and then the big three cloud 8%, an African cloud 5%, using their own machine 18%. That's actually very interesting. With the people who are using their own machine, if you can paste on the chat what machine you have, what kind of chip is there, that would be very interesting to learn. Yeah, so thank you very much. This is really cool. All right, so I'll switch back to this PDF on this side. You can see that Colab is a very big way people are using GPUs. 35% is the highest way people are using GPUs. In fact, you people are expert on this call. That's why you are competing on the ADTC challenge. So many of you are using the big three, and you even have your own machine. If you look at the more general crowd of developers across Africa, the Google Colab is higher, like 70-80% of how people are using. So that's how most people are getting introduced into AI. So it's amazing. But after you get introduced through Google Colab as a free tool, it's when you start to advance and you're trying to get gigs or a job or compete in an ADTC challenge, there are some limitations that Collab has that you need to kind of graduate from. And that's where this slide starts to talk about what are some of the things that you cannot do on Collab. And this is just a few. You people who are experts who do this every day. I keep saying that I'm a business guy. I deal with infrastructure. I set up GPU infrastructure in the data center. But after I set up, I hand it over to the data scientists, and you guys do what you do on the command line. I know some, and I will teach those today. But you guys are the real experts. You're the ones who are the AI engineers and data scientists. My own is to work on hardware. But these are some things I learned that don't work very well on Colab. For example, you're not able to run jobs for a very long time. If your laptop gets disconnected or you change your tab, close your tab, apparently the job will close as well. And you can imagine in many of our countries, often your laptop has to close now, right? If your battery has finished or if your internet, you get disconnected from your internet, it will close. And if it means losing your job, that's not very good. Also being in control of the resources of your machine, like how many cores, CPU cores, GPU cores, the RAM, the storage, you don't have as much control over that when you're on a tool like Colab. And there's just several things that you can do because it's an entry-level tool. That's why it's always it's great to graduate into using GPUs on a platform that gives you access to the full machine, like a virtual machine or a bare metal machine. And to do that, the biggest companies made that happen. Amazon Cloud, AWS, Google Clouds, Microsoft Azure, those are the big ones. But after them, several other companies, including us, now decided to create platforms as well that can also help you get access to GPUs. So for those of you who want to follow along, well, I'll move quick though. You might not be able to follow along like that. But yeah, you can go on GCP and find GPUs. I think I have a tab here that has Google Cloud open. So GCP, this is my Google Cloud account. And on Google Cloud, you're able to, it's now a big complex platform for a very long time. So there's a lot of things going on. You probably need to like watch YouTube and learn how to use it if you've not used it yet. But a very quick thing you can do here is on the search bar, you can search for, well, it's already even here, Compute Engine. That's where you will go and find the GPUs that are there, Compute Engine. When you're in the Compute Engine, if you have just created your account, it will probably ask you to upgrade to an account where you enter your credit card because obviously it's not free. So you enter your credit card and then you're able to rent a GPU. So you'll be creating an instance. And when you go to create instance, it asks you several things like you should give the instance a name, you should choose the region where the GPU is based. These are easy things to follow. The quick ones I'll just show is here you see some category of different kind of servers you can rent. I will click on GPUs, and then on the GPU one, I will select something like an A100, 80 gig. That's a powerful one. It'd be great but this is, it's a powerful one that you can get. Some of the older GPUs are here too. But yeah, this one, and if you're trying to get one of them, you will see the price on the side. They like to put it per the whole month, but I guess you should only be renting hourly, and maybe you need it for 5 hours or for 10 hours, right? So, $5 an hour here. So this is how you can rent GPUs from Google Cloud. So you can either get it from here, one of the big players, or well, we have AGH Cloud.ai, which for us it was how do we optimize for the African audience, currency, price, and some features that are useful. So that's another place to get it from. I would be using the one here. Basically, you go on clouds. Maybe you didn't see what I did. You go on cloud management, or cloud management is also here. To ask you to sign in, sign up. After you have signed up, you'll be able to click on instances or available packages, and then you can select a GPU that is here. You can select based on the region where it's based, or you can also filter based on the name of the GPU or the price, right? So right now I'm going to use price, and I'm going to use the ones that are cheaper than $1 an hour. If you want to move much faster, you can choose a stronger GPU. It's up to you. The fact that it's more expensive doesn't mean much. It will run faster. Only if maybe you switch it on and you're just allowing it to run and you're wasting time, then you're wasting money. But if you're actually running a job, the bigger the GPU, the faster you finish, right? So yeah, you can come and you can grab these GPUs and you're able to rent it. To rent it though, you would have added some money to your wallet, which you can just click on wallet, and you can use your Naira account as well, or African currency. But once you click on rent now and select the wallet that you're going to use, you click on confirm my rent. That's all. It's pretty quick. What happens is you now get, I'm trying to show you how to get to the command line I have running. It will show you that your GPU is going to be active. It usually takes like 3 to 5 minutes, and you'll be able to see the instructions on how to connect to it. If you click on that 3 dots and SSH instructions, you'll be able to see that the instructions. The first thing you do is that you will change the permission of your file, of your password file, after which you'll be able to now have your SSH instruction to connect to it. So if I copy this, for example, I'll go to my command line tool. I am using Git Bash. Go ahead for me.
Yeah, so I think someone in the chat is asking if you can zoom in your screen a little, if it's possible.
Okay. Let's see. So on the command line itself, let me see. I think this is zooming into it, so that's good. So I'll paste that command to SSH into the environment and press enter. So yes, I trust it. And so now I'm inside. Oh, permission denied. Let me see. Ubuntu exit. Oh, I was already inside, that's why. So on my own computer, this is my computer command. I was going to say something before. The people who have not used GPUs before, I should have also asked who is not comfortable with command line. Command line is quite important when you are working with virtual machines and in the AI space in general. So hopefully, if you're not comfortable with command line, you can just check on YouTube. There are several 10-minute videos that will give you good introduction to command line. Very important. But yes, on a command line, and there are many command line tools. If you're using a MacBook, Terminal is really good. It comes by default. But if you're using a Windows, you have to install one that is powerful. In my case, I use Git Bash. Just in case. I think this is getting recorded so people can see what I'm saying. So I use Git Bash. You can also use something called PowerShell. PowerShell is a pretty powerful one, as the name says, Windows PowerShell. It tends to have some extra permissions than the other ones, and you can even run it as an administrator to get more power. But yeah, back here, so I'm on Git Bash. I will paste the SSH command, and that will get me into the virtual machine. So it worked. I got into the virtual machine. Now it's telling me I'm now Ubuntu at Dell Lag, which is Delete Lagos. I created a virtual machine called Delete Lagos Dell Lag. So that's what that is. So now I'm inside the virtual machine. So once you've gotten access to your GPU, let's now go back to our PowerPoint. What does it say we should do? There are several big things I want us to cover today. I'm starting with the last one, which is your commands. It's useful to record everything that you run, all the commands you run, so that maybe the next time you want to open a new virtual machine that is completely new, you have the commands you ran before, you can just rerun them, right? So it's good to save them in a script. There is a command that helps you do this, and not many people are familiar with that. So that's a good one. The second one we'll talk about is something we built called envpod. So AGH envpod. It's if you're familiar with, some of you will be familiar with virtual environments. You create a virtual environment so that within that environment you can run some code there, and when you're finished, you can close the virtual environment. I think a lot of people do it for protection reasons, for example, where you don't want to break your full virtual machine. So you just create a small container inside called the virtual environment, and you can do things inside. We created one called envpod, where it's a lot more secure, and you can also use it to you can create a specific size that you want it to be. So far, I've not seen that with the basic virtual environment. You can size it, but with the envpod, you can size it. And that sizing is important here because I think with this ADTC challenge, you are trying to build models that can run on basic devices, like a basic laptop that has 8 gig RAM, or a basic phone that uses 2 to 4 gig RAM. You can use this envpod to create that a pod that is of that size, and then test whatever you have built inside and see, make sure it doesn't break and it's not failing, so that your final submission will work. So let me see. Without internet, yeah, eventually without internet. I'm just reading some other comments. The third one is being able to simulate resource constraints. Well, yeah, that's what I was just talking about. Being able to set the number of RAM and things like that. Another one is there's a tool called TMUX. It's really, really cool. This is one tool you can use to you will see how cool it is. You can create multiple tabs within the same command line. You can also create it such that your commands can be running in the background, even if your internet goes off, or your power goes off, like NEPA or PHCN. If it goes off, you're able to continue working. Or even you are taking a flight, but you want to start running a command before you jump on the flight. TMUX helps just keep things running. And someone that was saying about the internet, that internet piece, right? That's for when you have finished building everything. So you are deploying your product. But before you deploy a product, you have to build your product. You cannot build your product without the internet. At least I'm not aware of how you do that. Maybe some of you will create ways of building your product without the internet. But to build your solution, you are not restricted to, I'm just opening the comments again. I think it was Abdulaziz that mentioned it. You're not restricted to 8 gig RAM to build you can use 100 gig RAM when you are building the product. You can use one terabyte of storage. You can use internet. But after you build the product, you build a product that is small, tiny, that can fit into a small device. So I think that's a good thing for you to keep in mind. Right. So these are the big things we'll cover today. And let me now shift into going through them one by one. The first one is around the command for saving your session. Let me copy it and paste it. I think what I would do is, of course, after the session, I will share this PDF so it has all this information. Maybe that's the best way. Before I was going to say I will push it to GitHub, but maybe I'll just share the PDF. I'll just share the PDF. And here is that command, by the way. So yeah, with that command, it will give you all the things you run. On this very session, I've run many things already. So let me test it out, right? So if I paste it here, it will push everything I've run into this file, my setup script. And if I open the file, I use Nano. People use different editors on command line. I use Nano. When I press it, enter, you can see many commands that I've been running. So all your commands will be there. So it's a really cool one for saving the things that you've done. And when you do it like that too, since you're going to probably shut down this virtual machine, you should also push it to GitHub, right? So if you're familiar with GitHub, you know that you can commit your files. You should commit that file to GitHub or download it to your computer. However, it is you move your file so that you save that file for yourself. So that's that first one. It's pretty simple, easy, but it saves lives. Yeah, it saves lives. So the next one is around envpod. This is the one where I talked about creating that small environment or a pod within the big virtual machine. And to just show you what that looks like, let me even grab some things for the slide afterwards. This slide afterwards tells you what's the limit of your machine. So the first one shows us how many CPU cores are in that machine, how much RAM do you have, how much storage space. So let's just see. First of all, the first one, CPU cores. How many CPU cores are on this machine? There are 48 cores, right? So that's a lot of cores. On your laptop right now, maybe you have 16 cores, but on this virtual machine, we'll have 48 cores. How much, let's see this next one. How much RAM do we have? We have a lot of RAM, right? So this is like 235 gig. So it's a lot of RAM, but they say you should build for an 8 gig laptop, right? So this is a lot of RAM. So if we now want to size it and make it smaller, let's build a pod that allows us to do that. So that's what this slide is about. It tells you how to build pods. Pods, the first thing you do when you're building a pod is you have to download the using a script. You download the file. So let me just paste this. Probably take like 3 to 5 minutes to download. Blah blah blah. Okay, let me see. Because it's pasting directly from, let me open my command line, my notebook here. Yeah, because it's copying from my slides. It's affecting the format. So when I fix it like this, let's see if that would work. So that is one command instead of multiple lines. And then let me paste this back here. Okay, cool. Yeah, so that's to download the script. You would tell it yes, that it should install whatever it wants to install. It's installing Ubuntu, a particular version, and it's going to do several things there. So that's how that works to install envpod. I'm just pressing no here because I've actually installed it already. Let me see, 1 to 5. Yeah, I've actually installed it already. So you install the program first. That's what this command is. When you get the PDF, you will see the command for installing pods. I'll also put it on the chat. That's that command. And then an important thing to do is there's a config file that you use to tell the program what parameters you want in your pod, right? So I do have I included there's a blog we had written. This QR code goes to a blog that explains how to use pods. And inside that blog, there is a example config file. You can just copy and use that file. But to explain there's a lot inside. I don't think I should explain all of it here. But the biggest portion are the processor size, where you can tell it. Here we told it we want four cores, CPU cores, and we want memory of 16 gig, right? In fact, the one here, let me see, ls, and let me open my config.yaml. Is being edited by yes. When I open it, I can see, yeah, on this one, let me actually reduce it to 8 gig instead of 16. So that's how you can like change the parameters there to whatever you want. You can make it 4 as well if you're trying to build for a phone. So that's like the biggest thing you would be changing. The second thing you might decide to change if you're using a pod is that it also has a protection of what URLs are you allowed to go to inside the environment. This is for protecting, it's mostly for AI agents, so that AI agents don't like misbehave and go to places you don't want them to go. So yeah, you add some URLs that you want you approve of for it to go to. So with this one, yeah, if there's any URL you think your tool needs to use, you should enter it here. But as we were saying, this is eventually you use this to test what you have already built. And what you have already built is not supposed to be using internet. So you might not need to enter any URL here. But if for someone else who's building something that needs the internet, you type the URL in that space as well, right? So yeah, inside the file, this is a place where the URLs are. And since it's getting recorded, be careful when you enter it. Make sure you give enough space to match the other ones. Because it cares about that. So google.com, I can add google.com to this. But if I did it that it had one less space like that, the file will not compile. When you're familiar with command line and some of the pains, these are some of the pains. But yeah, you have to make sure it has enough space. Let me see. Okay, Abziz mentioned oversharing. I would have asked him why he's saying that. Maybe you can type more on the chat. Obviously, this pod allows you to do a lot of things. It's actually it's a very, very powerful tool, if I can say that. We are using it for the simple purpose here of determining the size of a processor that you would use. But there's so much more it can do, right? There's so much more it can do. Yeah, you're correct. So there's all those things it can do, but you don't need to care about that for your project. And those of you who know how to use it, that's even amazing. So please go ahead. Yeah, so I will save and come out of this file. And once you have your YAML file ready, you're able to now, let's go back to our script because we have our YAML file already. You're able to initialize your agent using the YAML file. You see it says sudo npod initialize. You give it whatever name, or you initialize your pod, right? And give it the YAML file. It will now create that pod. The next command helps you run the actual pod. We call it a GPU agent because it is an agent. If you want to call it pod, my pod, any name you want, you can call the whatever it is you have created. right? So in this case, I just called it that. So let me copy this one and run the pod. This then helps me go inside the pod. So once I enter the pod, I can see that it pastes out the properties of the pod, that it has 4 cores, 16 gig. I didn't change that early on. But yeah, so it has that listed here. So now I'm inside the pod. You can also see the name here changed, agent at GPU agent, right? So that name changed. If I want to leave, I can do exit, and it will go back to where I was before, Ubuntu at Dell lag, right? So let me go back inside the pod once more, which is sudo env-pod run. So that gets you inside the pod. And so once you're inside the pod, you can run whatever it is you want to run here. Echo, I am inside the pod. And then if, for example, you have your inference model that you have built, you can now test it here. You can bring it in using GitHub or wherever you have it. You download it inside. And then okay, I just finished some of the comments. You can download your inference model inside here, and then you can run it. You can use the commands we have on this next slide to check the properties inside the pod, right? So for example, let me check how much RAM is now inside here. And hopefully, so now we see 16 gig. But if you remember, for the full environment, it was 235 gig or something like that. But now you have only 16 gig that you have said you want to use to run your tests. So that's an important thing to do here. The rest of the things on the slide, this talks about a tool called Stress. It's used to run stress tests. If you ever needed to do that, you have the PDF, so you can play with it, and this helps you see, just to stress test your environment and confirm that it's the size that you think it is. If I should mention this as well, when you are running your model, if it runs out of CPU cores, it just gets a lot slower. But the biggest thing is if it runs out of memory, your RAM, right, it will actually stop. It will terminate your job, whatever it is you're running. So if your inference model was too big, that's what would be happening. And you won't be able to run it. So that means you still have work to do to reduce the size of your model and make it fit and be able to run on a basic laptop or that basic phone that you want to use. Last, as in Nigeria, let me say it that way. Last, you can actually take it to that. If you have that kind of machine in your copy, you have one, you can just go and run it directly there and see if it will work. But if you don't have one, this is a way to use this environment to simulate what it looks like. So that's a big thing I'm trying to teach here. So the next one we'll talk about is TMUX. This one is around just learning how to use the command line more and being able to, for example, create new windows within the command line. And I think the biggest reason people use TMUX is that you can have a job running, and even if they take light or your laptop goes off or your internet disconnects, the job will continue running, it won't freeze. So that's important when you're running a training job that takes 30 minutes or a training job that takes 6 hours. You don't want it to freeze, it's waste all your money that you have. In fact, on this one, I'm not an expert on this one. I just love using it, but the experts know more. I don't know. Maybe I call Isabella or Julian. Julian, are you still with us? Is this a tool
Yes, yes.
you use? And is it why do you use TMUX?
Yeah, I use Tmux very, very often, but I use it every day. All my coding agents, I wrap them in a Tmux session. And the reason is pretty much what you said, right? So there are several reasons I use Tmux. If I close my laptop, or for some reason for some reason I can't do my work or something, this session is persistent because the Tmux wraps the terminal session the way you would typically just use the terminal. Then also I have an app on my phone that allows me to log into Tmux sessions running on my laptop. So if I have a Tmux running on my terminal, on my laptop, so long as I have my phone with me, I can actually like log into those sessions as well and talk to my coding agents and do whatever I want. So yeah,
That's
so
very cool.
yeah. So Tmux just gives you all kinds of. So it just allows you to wrap a terminal and just
Mhm.
make the terminal more persistent. That's just really what it does, and then you can split, do it several tabs, all kinds of cool stuff.
Mm-hmm. That's very interesting. I didn't know about the phone one. So yeah, now you could just check everything on your phone. That's very cool. So I'll clear my screen and I'll start using some of those tmux commands. So for example, this is the command on how you is a tmux like that. This is the command on how you create a new tab, right? And let me call this tab 0. So I hit enter. It's created a new tab. At the bottom, I'll see here. So tab 0 is what this is called. Let me just, so that we know what tabs we're in, I'll say I am 0. If it has a GUI. Well, the world of command line. No, when you're a bad guy, you use command line. No GUIs for the bad guys and girls. You have to use command line. I remember the first time I saw command line, I went for post UME in Ilefe, and I saw some computer science guy. All his screens were just black, and he was a Linux guy basically, and he was a
Yeah,
hacker. I just saw the guy. I was like, man, I was 15 years old.
looks
I was
looks
like,
really badass.
man, yeah. I was like, wow, like, what's this guy doing? Look at
Guy's
this
hacking
crazy
NASA,
stuff.
so he's hacking NASA or some crazy stuff like that.
Yeah, man. Yeah, yeah. It's just like some of you guys on this call now, you know. But I was a 15-year-old seeing this dude with his big black screen. Like, what is this guy doing, man? And I'm here to write post UME, English and mathematics. Yes. But yeah, back to the scheduled transmission. So I said echo I am 0, and let me create a new one which within the tmux environments, you use Control B, you press Control B, and then you remove your hand, and then you can press other commands. If you press C, you will create a new window. If you press N, you will go next or B or previous window, N or P. If you create 0, you will jump to 0, the first 0. If you press 1, you go to the second one. So these are just commands on how to go from tab to tab. You don't memorize this. You have this slide. And if you Google it as well to tell you all the different things. So no need to memorize, but you can just see how I move through them. So for example, I'm going to press Control B and I'll press C. That will create a new one. So on the bottom here, we only had 0 before. Now we have 1. If I press again Control B and C, it will create another one, 2. So now I have 3 different tabs and I can run different things on each one. If I'm moving from one to the other, I'll press Control B and P. That will take me back to tab 1. And how do I know this star is next to it? Another way I can know, let me just echo I am 1. Right? So that way it's printed it there. Let me now do Control B and N, which is next. You see, there's nothing here. Let me echo I am 2. Right, I am 2. So now if I press Control B and N, it's going to the 0, 1. Control B and N is going to do 1. Control B and N is going to do, hopefully that has attached our brains now. So yeah, that's how you use these different things. I can choose to rename a window, which is, cool, where I can do, let me see. Yeah, Abdul said the command line scares him a lot. It's sweet eventually. Control B and you now press comma. You can change the name of the window. So let me actually, right now I am on 2. So let me do Control B, comma. It went down here so that I can change that name from bash to whatever. Let me call it second window. Right, enter. So now down here it's called second window, right? So it has an actual name. So that's just how you do those Windows things. A really cool one is in terms of even this one, split and monitor. Splitting the windows is really, really cool. Before doing that though, let me instead show detach. This is how you can detach from a session. Basically, you step out of the window even though it's running something, right? So for example, maybe let me go to I am 0, the first one, and here let me do watch NVIDIA SMI. NVIDIA SMI is a command you use to see what NVIDIA version you have and some different parameters, right? So right here, we see we have a A100. We are using only 26 watts of power instead of 400 watts of power, and many other parameters, right? So this is now running on my 0. So to detach from all of this and go back to the command line environment, is D, Control B and D. That detaches you from that space. So Control B and D, you come back to your regular environment. You see all those things on the bottom, they've all gone, right? And so at this point, after you detach, you can actually like close your laptop or disconnect from the internet, but things will just continue running in your TMUX. And then when you want to attach back to it, you press TMUX A, right, which is down here. TMUX A will attach you back to the last one that you left. There are other commands here where you can do TMUX LS, which will list all the sessions that you have. Let me actually do that one. TMUX LS will list that you have 3 windows, 3 windows running. It only said how many. It didn't list them. Maybe that's something I'll just check to see how it's supposed to list them. But yeah, TMUX A would attach you back to the last one that you had going on. So you see, now I've come back into the TMUX environment. So that shows you how to go in and out of TMUX. Let me do Control B and go to the second one. So I am 2. From here, there's something here called split screen. This one is pretty cool too, where if you split the screen, you can maybe have something that are monitoring the job in the bottom while you're working. So you see how things are going. I'll show you. Control B and you press this what's that? It's a quote symbol, right? So if I do where am I? Let me clear the screen. Okay. And say Control B and then that quote symbol, it will split the screen into 2 different things, where on one of them I can run, this is just echo bottom, right? So you just split the screen so you have the thing on top of each other. To go to the one on top, I think you press Control B and you use up arrow, it will come up there. So you see I'm up there. If I want to go down, Control B and down, it will come down to the other one, right? So that's what's written here, Control B, up and down, right? So that's how that works. And so why am I setting it up like this? Is because, well, I personally like to use the bottom one to run some monitoring jobs. So for example, I want to monitor how much CPU usage and memory I'm using, while on the up job, I'm like running the actual interesting thing. Yeah. And by the way, I know we're almost coming up on time too, but we've covered quite a bit of commands here, and you will have the sheets to use with you. Let me just quickly do this one where I'll run H top on the bottom one. So let's do H top. H top is gonna print out like a lot of information, which to people who fear command line, they will hate looking at it. Our friend Abdulaziz. Let me see here. Because so this yeah, this might just be so complex to explain on this call that we have a short time. But htop is a command that helps show you your usage. These are things that you should Google. Google is your friend, especially now that Google has AI mode, right? You can just ask it any question about these commands. It will explain them to you pretty quickly. But yeah, these are just some commands you can use to monitor things when your environment starts to freeze. You don't know what's happening. Also, if you get any errors with anything, you can just very, very easily take a screenshot and paste it on Google AI mode and say, why am I getting this screenshot? So for example, I don't know if I can maybe simulate some error. Python 3, but that's the wrong way to do Python. But let me just do that. Python 3, blah, could not find database, whatever, right? That's the wrong way to do that command. So I did it wrong way on purpose. Let me take a screenshot of that. I'll take a screenshot of that. And then that screenshot, I'm going to go to Google AI mode. I'm trying to run a code and I'm having some errors with it. Let me open this. So I got this error on my code. So you see, once you paste the screenshot, it will just try and explain to you that, okay, you're supposed to write it with the 3 next to the Python. I think I put a space between them to fix that error. And if you do that, it will fix it. So that's something you can do on your own as well, even before reaching out to people. So that helps. So now let me see what other slides are here that we might not cover. This one says you can kick off your job and you can walk away, or you can lose your internet. It will still work. I think I've shown that already, where you detach from it and it will still keep running. The next one talks about being able to deploy your model. The slide is here, so you can use it. I'll probably skip this one. It's just, well, quickly, there's a page on the AGH dashboard that allows you to be able to deploy what you built for people to use. You would go to there's a deploy button, and on that deploy button, you would be able to decide what virtual machine you want to use, which is pretty straightforward. Like, oh, I want to use GPUs in Lagos. I want to select one of these virtual machines. But the place where you define what gets run is where you say, oh, I have my own app. And yeah, I have my own app. The platform to rent GPUs, AGH cloud.ai. You can also use others though, GCP, AWS, Azure. You can also use those. But yeah, you enter, I have my own app. That's where you're able to put like a link to your GitHub, the startup command that you have written. It usually comes in the form of like a pip install -r requirements.txt and then Python, whatever your app.py. It follows a similar format like that, and then a port where it's running. Once you have those things, you can click on provision and run. It will host your application you have built and people will be able to use it. That's something we can maybe talk about later as well. The slide has an example of someone's, GitHub. It's called Mansa. Mansa Nano is a very tiny model, $100 model. It's a tiny model, but it proves that you can build a model for $100, which is kind of cool. So this is the start command. If you paste it and the port number, and you can host that model. So after those, I think I will now. I thought it would even take a shorter time. It took the whole time. But yeah, just to go high level, the big tips that we'll cover today. It's good to have a script that will copy all the commands that you have run. Using fpods is the way to when you are testing, not when you're building. You can use it when you're building too if you want, but mainly for testing. After you've built your inference model and you want to test whether it can run on the simulated environment, you update the config file and you can now run it inside inside a pod. And then using TMOX is also really great. It can help you not lose your jobs if, like, maybe, they take the lights or your laptop goes off, right? So I will pause there and see if there are a few questions we can take, or if there's any comments from the organizers, since I see that time is now short.
Thank you, Alex. Thank you so much. Yeah, so there are some questions in the Q&A. And we'll just get right into it because we're almost at time. So Marvina is saying, given that many teams already rely on Docker or Kubernetes for instance isolation, what specific edge cases or security failures make AGHF pod necessary over standard containerization on GPU VMs?
Yes, it's a great question, and I think perhaps we'll publish like a table that compares the different approaches. I thought it was here on this blog, but maybe it's not there. The different approaches have different things they bring to the table, and it's just a case of how many of them do you have, right? You talk about Kubernetes, but here this table just talks about virtual environment VM, right? This VM helps you do dependency isolation, but if you're trying to isolate in a deeper level, like system, network, file system, it doesn't do that really well. Auditing of logs, I don't believe it audits. It tells you, like with the secure pod, there's an audit command you can run that will tell you everything that has happened. So if, for example, that's why it's good for agents. If you had an agent running, you can use this to see everything the agent has done. So if I come here and I say exit, I'm still inside the agent, right? So if I exit that agent, let's see, exit. Let me do Ctrl+B, detach, and then I exit from here. So now I'm back to my regular terminal Ubuntu, right? If from here I can check my agent and type, instead of run the agent, I want to do audit. There'll be so many commands. It will tell me everything that the agent has been doing, and then all the timestamp of every point where everything happened. So if, like, you are deploying something for this chief security officer of a bank, they're going to be asking you this kind of questions. It's like, what did the agent do? What did all this stuff? Yeah, I think it's very difficult to do it with other platforms. I stand to be corrected. But over here, it's pretty easy. You can just do audits and you get all your information back. And there's more to it that we can share offline. But yeah, this article shares quite a bit. So cool. We can go to the next question.
All right. And the next question says, right now, after I forked the template, I cannot make the repository private. What should I do to protect my work? I think this is to either Julian or Bolan, if they can respond. So I think this person is asking with relation to the challenge. There's a repo they are supposed to fork for their submission. I think that's the question. So if Gillian and Bolan will take that, but we'll go to the next one about your presentation. That's simulating CPU and RAM limit is straightforward with C groups, but how do you effectively simulate hardware level GPU VRAM and bandwidth constraints on a live VM without introducing artificial overhead?
The FPod don't introduce any overhead at all. You get everything completely clean, but the FPod allows you to do CPU and RAM. I'm not sure it does VRAM. I have to check with our dev on that. That's a good question. Let me copy and save what you've said here and get back to you. Also, C groups I have not used before. Probably that's a good one too. All right, thank you.
All right. Thank you. The next question says, when reducing inference resources for cost optimization, what evaluation framework or threshold do you use to ensure model performance doesn't quietly degrade below acceptable limit?
Other performance doesn't degrade. That one is your job. Oh. That's the competition. Is that when you reduce the size of resources a model needs, how do you keep the quality high? On that one, I will ask maybe the judges or the creators,
Well,
Bolanho and
but that's
Julian.
what they're supposed to work on.
Yeah, I was gonna ask, is there any expo that is allowed to be shared or any guidance
Mm,
that can be given? There can be.
well, oh, probably, but I mean, this is not an expo session. It's an
Okay.
info session. So,
All right.
so but Marvina, I'm sure that yeah. So, but Marvina, you can ask your questions on the Discord channel, and other people who are building alongside you can also share what the experience is and how they might be willing to open up and help you. But overall, that's exactly why this challenge was created, just so that we can now begin to optimize. I'll share the link shortly in the chat. We can begin to optimize these models as much as possible, as high as possible. So yeah, that's the challenge. Just give me a minute. I'll share the Discord channel and then I'll read the next question.
Yeah, I
Okay.
see one that says since the teamwork session is tied to the host machine, so as long as the host machine is running, even if your internet cuts off or your laptop goes off, you are fine because teamwork will keep everything running. But if the host machine goes down, that's what Marvina is asking, then we're all in trouble. The host machine is not supposed to go down by itself, and hosts companies usually have an SLA to prevent this from happening. Instead, what could happen is that you yourself, you might shut down your machine because you're trying to save money, which is fair. So when you shut down your machine, then it means the jobs you had there or the data you have there will not be there anymore. That's why we say that you should run that script to at least you know the script you ran before so you can run them again. It might take you 5 minutes, it might take you 20 minutes to run those things again, but at least you have those scripts. Beyond that, that's all I should say. But I know that in the future, there will be some ways to maybe export the states of your machine and export it to like GitHub or somewhere. So next time you can just download it back and start from where you stopped. But that's not something we have now. Yeah.
Okay. So next question is, when reducing, okay, no, since teamwork sessions are tied to the host machine, I think you just answered that, yeah. Uh,
Yeah.
so
Yeah.
given the steep keyboard shortcut learning curve and configuration drift across different environments, how do you standardize teamworks.conf setups across a team so developers don't waste time troubleshooting local key binding issues?
The learning curve is if you know command line, the learning curve for teamworks is not steep. It's actually pretty straightforward and easy. But if you don't know command line, the learning curve is steep because it takes practice learning to type into an environment that looks like that, black and white, and a lot of errors happen when you're doing that. I completely understand. I remember the first time I started using command line. Um, yeah, it can be difficult, but typically developers I don't know if I should say typically. Ideally, developers know how to use command line. And if they know how to use command line, Tmux is just an additional command for them. And all they need to do is receive the slide PDF that we use for the presentation today, because all the commands are on the PDF. And outside of this PDF, you can Google. Once you Google it, you get the information of what you need. On this page too, there's one that says see all commands. If you do Control B and question mark, it'll show you all the commands that are within that can be used. So yeah, well,
All
cool.
right. Okay.
Probably
Thank you.
we'll
Thank you
come to a
very much.
close.
Yes, yes. There are no more questions for you. There are questions for the challenge, and it will be addressed. Please, Ahmed, please join the Discord channel. We would have the team members address your questions on the Discord channel. Please join. I put the link in the chat. But thank you to everybody who's on. Thank you. Thank you for engaging. Thank you for sharing your questions. Thank you for the responses. And I mean, the chat place was quite interesting. So thank you. Thank you very much. Like Alex has said, we'll share the PDF for this session on the Discord channel. So it's going to be available to everyone who wants the command and everything that is shared, including like the different comparison with the different cloud platforms for GPUs. We'll share that. And also, this webinar is going to be hosted on YouTube. So it will be hosted, and when the link is live, we'll also share that on Discord channel, so that whatever information Alex is gladly shared with us today for no cost, for no cost, would you'd gain access to it. And we really just want to mention that Udu Technology is also partnered with Africa Deep Tech Challenge to distribute GPU credits. So if you've not seen the link to request for the credit, please check the Discord channel. There is a link to request. Not all requests will be approved. Let me just give a disclaimer. We're only going to approve requests that shows high need basically for the GPUs, because some people, your project might not need a GPU. You might really just need to build on your laptop and you're fine. But if you really need the GPUs, you can apply for the credit and you get them courtesy of Udu Technologies. Okay, without further ado, we'll bring this session to a close. Thank you so much, everybody. Thank you, Alex, for making time to host the session. I really learned a lot. I mean, most of the things that this first time I'm seeing them, I'm like, "Ah, so this one today." But thank you very much.
I remember the first time you learned command line. And for people who think command line is scary, Fumi is a proof that miracles are possible. Fumi is a business person, true and true, but I don't think, yeah. I commend you. I commend you. I didn't even expect that. One day you just showed up and said, "Oh, look, who I'm learning command line." I was like, "Really?" So
Oh
yes,
no, but okay,
that's
I think
amazing.
that's proof that everything is possible as long as you're willing to learn. So yeah, so please don't be scared by anything that Alex has shared today. And you can always reach out to Alex on LinkedIn. I'm sure Alex is one of the most responsive people that you see, and he's super busy, but he's super responsive. I don't know how he does it, but you would have all of these resources at your disposal to ensure that whatever you build, you have everything that you need to churn out a very great submission. So we're looking forward to seeing what you build. Thank you, everyone. Thank you so much. Please enjoy the rest of your day, and we'll be ending the webinar now. Thank you. Bye.
Bye.